Once again, you're welcome here with Some Academy. Now let's take a look at sequence part 2. In this sequence, we're going to start with arithmetic sequence. Okay, we take one example for arithmetic sequence, one or two examples for quadratic sequence, one example for cubic sequence. So that's what we're going to do for today's class. Now, let's take a look at using another way, different from the part 1, what we did in part 1, where we look at position to term rule, and we also look at not only position to term rule, we also look at position term to term rule. So in part 1, we looked at the way to find the nth term using the position to term rule. Okay, the way to find the nth term, this is the position to term rule, and we also look at the way to find the next term in the sequence by following the term to term rule. Okay, which helps us to find a common difference. So for today's we're going to look at another trick, another way of doing it, using a table. Okay, using a table to find if the difference between the first term is find the nth term of this sequence. Look at the sequence is 7, 12, 17, 22, and 27. So if the difference between this, the second term, this is the second term, okay? This is second term, okay? Each one is a term. In a sequence, each one is a term. This is the first term, this is first, okay? This is first. That's why we call it position 1. That's why we gave it position 1. Other position, we are just naming them according to how they come. This is second term and it's position 2. This is third term. 17 is third term and is position 3. 17 is third term, that's why it's position 3. 22 is fourth term, that's why it's in position 4. 22 is fourth term, that's why it's in position 4. And 27 is fifth term, that's why it's in position 7. So n is used to represent position. N is used to represent the position. An is used to represent n term. Either we use an or we use the n term itself like this. Depending on the text, we can use n term like this, meaning either we use an for the n term or we use the nth term, write it this way. The nth term, we can write it this way, n to the power of th. Okay, so each of these represent the nth term of the sequence. Now, how to do if they say find the nth term of this sequence, you don't know whether it's arithmetic sequence or geometric sequence or even quadratic sequence or cubic sequence and so on and so forth. So how to find out is to find the first common difference. We find what we call the term to term rule. So we can say first difference and make another column or another row for this table, first difference. If the first difference is already same for all, if I do the difference between second term and first term, third term and second term, fourth term and third term, if I do the difference and if the number is all same, then it's a linear sequence, then it's arithmetic. Then it will be a linear sequence, which we call the arithmetic sequence. But if we find the difference between the second and the first, for example, the difference between the second and first is to say second minus first. So it's to say 12 minus 7. 12 minus 7, which gives us positive 5, right? Which gives us 5. So the first difference is 5. If you like, you can write plus, if you like. But whether or not, you already know it's positive 5. Then the difference between the third and the second, you do it again and find out the difference. The difference in this regard is, but we're using another method, okay? Not the one we used in the first part 1. Okay, we'll show you another way to do this arithmetic sequence. So the difference between the third and fourth, 17 minus, third and second, 17 minus 12, you get 5, also positive 5. The difference between the fourth and third, you find the difference again. That difference will be 22 minus 17, and that gives you also 5, positive 5. The difference between the fourth and the fifth and the fourth, is to say 27 minus 22, which also gives you positive 5. So what you see is that the common difference, the first difference between one term and the next term is all same. Since they are all same, this is a linear sequence. So since they are all same, this is a linear sequence, where the n term will be, the n term of this sequence will be equal to an plus any constant you like, an plus b. Okay, an plus b. So the n term will be obtained by, say, an plus b, where n is the position, right? 1, 2, 3, an plus b. So we're going to make another table. We're going to make another table to find the difference, what we call the an, to find the a, to find that a, so that we can get a. We find a and b. We're going to find a table, an plus b. Okay. So we're going to draw another table to solve this, to mimic this, to compare with this. So this method is called method of comparison. Now I will make another table quickly. Oh, the line is so not nice. Okay, so this is position. If we like, we just write n in it. Position. And this is the term. And this is first difference. So we're lucky enough, this is a linear sequence. So the first difference is same. All the first difference are same. So we go to represent that here. Okay, so this is our first term, second term, third term, fourth, fifth. Okay, so now here what we have is, remember, we're going to use the formula to fill the term. We're not going to write the term 7, 12, 17, 22, 27. We're going to use a formula. This is our formula at the n term. The n term for linear function is like the gradient. This is like x plus b. Remember this equation, y equal to mx, they're similar. Y equal to mx plus c. Okay, they are similar. Every linear function is like this. Every linear function, meaning it's an arithmetic function. The highest power is 1. The highest power of n is 1. So it doesn't have more than 1. So where this a represents this gradient n, this x represents this n, and this b represents this c. They're same. Distinct distance. The n term represents y. So it's a linear function. So when you have a linear function, then you define what is here, where n is 1, because at position 1, n is 1. You know this position is also n. This position is n. This position is n here. Here is n. So where n is 1, you put in this formula. 1 times a is a, so you write a plus b. B is a constant, so you just write b. A plus b here. The first one will be a plus b. So the second one will be what? N will be 2. So you replace here with 2. 2 times a is 2a. So here you have 2a plus b. Here you have n is 3. 3 times a, you have 3a plus b. 3a plus b. Please pay attention, okay? And then here n is 4. You have 4a plus b. 4a plus b. Here n is 5, you have 5a plus b, right? 5a plus b. You have 5a plus b. Now we're going to find the difference. You know what we did? We were looking for difference. When we're doing this table, we're finding the difference by say 12 minus 7, we got 5. 17 minus 12, we got 5. 22 minus 17, we got 5. So we're going to do similar thing here because we're doing comparison. Find the first difference. For the first difference, we say 2a minus a, that will be a. 2a minus a will be a. And then b minus b will be 0. So no need to write 0. So here, we only have a. Then here, we will find the difference between 3a minus 2a, we have a. And then b minus b, that will be 0. No need to write. So you see the difference is same. 4a minus 3a, you have a here. B minus b, you have 0. So here, 5a minus a, 4a, you have a. And b minus b, you have 0. So you can see the difference are now same. It's also like this one because we are making two tables for comparison. So we're going to find a and b now. Now a, this location, let me use a different highlighter. Okay, let's use pink and purple. Okay, now you see here, first difference, you now say compare, do a comparison. Compare the locations of the two tables. Okay, comparison. A location of the two tables, position A and location of two tables. So A will be automatically equal to what? A equal to what? From here. A will be equal to 5, right? A equal to 5. Now B, let's find B. We will compare this A plus B. We will equate it to what? 7. Because this is the exact location of this place. The exact location of this place is this place. Okay, so we compare that and we solve the problem. So you say A plus B is equal to 7, right? If you look at the two tables, if you compare the locations, if you compare the two locations, here is the term. For term, here is A plus B. So for term here, for this table, this location is 7. So you will say whatever is here equal to whatever is here. And just like we did here, we say whatever is here was equal to whatever was here, right? So remember, you already found A. A is 5. If A is 5, you just substitute 5 plus B is equal to 7. Is equal to 7, right? So you bring B to this side. You say B, you make B the subject of formula. B will be 7 minus 5. 7 minus 5, and that will be equal to 2. So B is equal to 2. B is equal to 2. Now we found A and B. Remember our formula, our function for linear n term is just an plus B. So since we found A and B, that it means that we've obtained the n term. So the n term of this sequence, will be equal to, let's substitute the value of A and B into the function. Remember the function is an plus b, right? This is the function, an plus b. So we're going to substitute the value of A and B to this function, and then we get the n term. So the n term, which we can write like this, or we can write like this, an, as we used the connotation yesterday for part 1 of this video. Then we said this is equal to A was what? We calculated A to be 5. So this would be 5n. What is our B? When we calculated B, you say 5n plus B was what? B was equal to 2. So you say 5n plus 2. So this is the n term of the sequence. But we have another easier way for arithmetic sequence. If you don't want to use this table, if you fill the table, this table is very important for quadratic sequence and cubic sequence. The comparative tables. These two tables, comparative table is very important for quadratic sequence and cubic sequence. But for arithmetic sequence, for linear functions like this or linear sequence like this, there's an easy way of doing it. you can just use this formula instead of using the table. The table may take a longer time for you to figure out. So you say the nth term is equals to A. We define A in this regard as first term, A plus, then you put a bracket, A plus bracket n minus 1 multiplied by D. D is the common difference. For this formula, these are new parameters. We have to define them now regarding this formula. Okay, with this formula, we already know what is n term. Okay, now for this formula, A is the first term. A is the first term for this formula. If you use this formula, A is first term. N is number of term. N is the number of term. Number of term. N is number of term. And D is the term to term rule, or what we call the common difference. Common difference between first term and second term and third term, fourth term and fifth term. That D is called the common difference. The difference between each term. The difference between each term if it's an arithmetic sequence. So the D is called the common difference for this formula. So if we're using this formula to find the n term, it's very easy. For our sequence, let's go back to our sequence. For our sequence, the first term is 7 and the difference is what? 5. The difference is 5. So we already know that A is what? 7 for that sequence. A is 7 and D for this using this formula, D is 5. So we use the formula, we substitute. We use the formula, we substitute it to the n term. So we say the n term is equal to the first term, which is 7, plus bracket. If you don't want to do the table, bracket n, number of term we don't know. So you just write n minus 1. You write n minus 1 multiplied by 5. Common difference is 5, right? D is 5. So multiply by 5. We're going to use this 5 to multiply this bracket. So we have the n term. We have the n term. N term is equal to 7. Okay? The 5 times n, it will become plus 5n. Because I use the 5 outside to multiply the n. It will be 5n. Then 5 times minus 1, that will be minus 5. 5 times minus 1, that will be minus 5. So you see the number and the number, you will add or subtract them. And then you write this one separate. So the nth term will now be equal to 5n, right? 5n. Then 7 minus 5 will be what? 2. So 7 minus 5 will be plus 2. So we write plus 2, which is same, using this formula, which is same as what we got when we use the table. Okay? I think the formula is pretty easy. Look at when we use the table. Look at what we got. We got the same thing, 5n plus 2 when we use the table. Remember this. When we use the table, compare table, we got 5n plus 2, and when we use the formula, we got 5n plus 2. So you can either do any of this. You can either do any of this, okay? Now let's use the table to find another example, okay? Oh, now we go to quadratic difference. Let's go to quadratic difference, where you must use the table. It's easier to use the table for quadratic sequence. Are we ready for that?
Yes.
So we say quadratic sequence. Quadratic sequence. So sequence, I just write sec. Quadratic sequence. Okay. Now for quadratic sequence, it's when the power, the n term, will be defined by second level. The highest power will be 2. So n term will be what? Just like you have in your case of quadratic function. The highest power in this regard will be what now? It will no longer be 1. The highest power is 2. The power will be 2. Right? Are you with me? So this will be This will no longer just be an term will be an square. The highest power of n will be 2. An square. You know, when we had linear functions just now, n was equal to 1. The highest power was 1. Then now plus bx plus bn. We're using n, not x. We're using n. Then plus c. This will be the quadratic representation, just like you have in graph, in the algebra. You have y equal to maybe 2x squared plus 3x plus 5. For example, okay, this 2 is this a, for example. This n is x. See, the power is 2, highest power is 2, highest power here is 2. And then this b is this 3, and this n is also this x, equivalent by comparison. This is 5, is a constant, 5. So this is how quadratic function is being defined. This is how quadratic function is being defined, meaning the highest power is 2. Highest power is 2. So when you have this, how do we solve this type of sequence? When we have a sequence, or how do we even know that this sequence is a quadratic sequence? How do we even know that this sequence is a quadratic sequence? You know a sequence is a quadratic sequence when you find the first difference, the first level difference, and you see that the numbers, the difference are not same. The difference are not same, and they are only same when you find the second level difference. When the second level difference only tally with same numbers, that's when you know you have a quadratic sequence. Now let's take a look at an example that he said deduce the n term, the rule for the n term for the sequence. Deduce for quadratic, number 2. Deduce the rule for the n term of the sequence. Now let's write the sequence. Okay, so we have, for the sequence, we have the first one is 0. We have 0, 7, we have 0, 7, 18. Then the next one 33, and then the next one 52. Okay, this is the sequence. We'll be given this sequence. They say we should find the n term of this sequence. So when you look at it, if you find the first difference, you will see that the first difference will not be same, because the difference between this and this, the second and the first, is 7. But the difference between this and this is not 7, it's 11, somewhere around 11, right? And the difference between the fourth and the third, they're not same, it's not also 11. It keep increasing. So you can see when you find the first difference, you don't get the same thing. So when you have that, then you know it's only when you get the second one, you get the same, then you know this is a quadratic sequence. Now let's show it in a table. It will be clearer when you see it in a table. Okay, let's have a table to expatiate on that. So let's say we have this table, and this is our position, and this is our term. This is our term, okay? And this is our position. Position is n, okay? Position represent the n. Position. This is our position. Position represent n. Okay, so 1, we have 1. We have 2, position 2. We have position 3. We have position 4. We have position 5. Okay, now these are the term that is given to us: 0, 7, 18, 33, 52. This is the sequence that is given to us. This is the question. Now let's find this difference. Let's find the difference. Let's find the difference. Okay. So this is first difference. First difference. Okay. Then this is second difference. This second difference. Okay, so the difference between this and this is what? What's the difference? 7, right? The difference between this and this is what? 11. The difference between 33 and 18 is what? 15, right? Is it 15? Then the difference between this and this is what? 19, right? 19. You see, when you did the first difference, they are not same. So it's not a linear function. It's not an arithmetic function. It's only arithmetic function if the first level difference is same of the second and the first term, third term and second term, fourth and third term, fifth and fourth term. So when they are same, that's when you have arithmetic sequence. But now the first difference is not same. So we're going to do second difference. Now what's the second difference? 11 minus 7 you get 4, and 15 minus 11 you get 4. See, for second level you get same difference. 19 minus 50 you get 4. So when you do the third level second level difference, you have same. So since it's at second difference, then it means that this is a quadratic function. If it's a third difference, you do another one, third one to find the same difference, then that will be a cubic function, a cubic sequence. So this one, since you can find the difference at second second level, then it means it's a quadratic. Is that okay? Now let's make another table for comparison. Another table of ours for comparison. Another table of ours for comparison, right? So here we have I'll just write n here. You know it's already positioned. I'll write n term here. You know it's the term. I'll write D1 here. You know it's first difference. Then we need to add a second difference to this one. So I'll write a D2 here, second difference. So here is 1. There's 2. There's 3. There's 4. And here is 5. Okay, here we find using the formula. You remember the formula? N is 1. This formula. N is 1. So 1 square is 1 times A is 1. Is A. So sorry. 1 square is 1. 1 times A is A. So here I have A. Let's choose a different color. Here I have A plus, and then the B is 1 also, and N is 1, sorry. n is 1. 1 times b, you have b, then you say plus c. So here we have a plus b plus c. That's what we have here. Here we have what? Here we have n is 2. Remember the formula? So 2 square, that's 4. See, 2 square is 4. 4 times a is 4a. There 2 times b, you have 2b, there plus c. Okay, so here you have 4a. Don't be wondering how we got 4a, because n is 2. So you say 2 square 4, because it's an square. So n square, 2 square is 4. 4 times a, you have 4a, plus, bn. Since n is 2, 2 times b is 2b, plus c. That's what we have here. For the third one, similarly, n is 3. 3 square is 9. So 9a plus n is 3. 3 times b is 3b plus 3b plus c. So for this one, 4. N is 4. 4 square from the formula. I'm squaring that from the formula. 4 square, 16. 16 times a, I have 16a. So I have 16a plus b, 4b, that's 4b, because n is there, 4, plus 4b, there plus c. Then for the fifth one, n is 5. 5 square is 25. So I'll have 25a plus 5b plus c. Okay, have we had this? Now we find the first difference. We find the first level difference. What's the difference between, we'll just write, okay? What's the difference between 4a minus a is 3a. So I get 3a here, right? 4a minus a, 3a. And then 2b minus b, you get what? B. You get b. 2b minus b is b. C minus c is 0. Then you find the difference between this and this. What's the difference between 9 minus 4 is 5. So I get 5a. I get 5a here. 3b minus 2b, I get a b plus b. C minus c is 0, so no need to write that. Then you find the difference between this and this. 16 minus 9 is 7. So I get 7a. 4b minus 3b, you get a b plus b. Then the difference between this and this. 25 minus 16, that's 9. So I have 9a plus b. Now let's do the second level. You see, first difference is not all same. What is here is different from what is here. And what is here is different from what is here. And what is here is different from what is here. So let's do a second level difference. The second level difference to say 5a minus 3a, you get 2a. b minus b is 0. So you get 2a here. And then 7a minus 5a, you get 2a. And 9a minus 7a, you get 2a. So we all got 2a everywhere. B minus b is 0. So you see second level is the same. Second level difference is same. So since we have got a table that tallies, we will not do comparison. To find a, you have to do comparison. To find a, you have to compare this place with this place. Is that okay? You have to compare this place, 2a equal to 4. You have to say this equal to this. And 3a plus b is equal to 7. This 7. Because remember, this is the first difference here. Okay? So 3a plus b equal to 7. Now let's see that 2a, let's find a. 2a is equal to 4. A will be equal to what? A will be 4 divided by 2, which is 2. A equal to 2, right? A is equal to 2. So we found a to be 2. What will be b if a is 2? Because you got to equate this one to 7. So you say 3a plus b equal to 7. And you already know a to be what? 2. 2 times 3 because a is 2. 2 times 3, you get 6. 6 plus b equal to 7. So b will be what? 7 minus 6. You bring 6 here to this side. 7 minus 6, b will be equal to 1. Okay? C will be what? C will be, a is 2. 2 plus 1, that's 3. Plus c equal to 0. Right? Equal to 0. So 2 plus 1, that's 3, plus c equal to 0. So you move it to the other side. C will be negative 3. C equal to negative 3. Right? So once you have this, okay, our writing space has elapsed. Okay, we can only explain from here onward. Okay, our writing terms has elapsed. Okay, so we've gotten A, B, and C, right? We've gotten A, B, and C. We've got it A, B, and C. So now what is the end term? I want you to write the end term yourself now. Now you've found A, B, and C. What is the end term? What is now the end term? Wait, where is the board, okay? Okay, now you have A, B, and C. So our end term, we can no longer write, okay? Our end term is what? A(n) squared plus B n plus C. Now you found A. Instead of saying A(n) squared, you now say 2n squared. 2n squared. In place of A, you put 2. So you have 2n squared plus, what's the value of B? B is 1. So plus bn, you say plus 1 times n, which is n. So 2n squared plus n, c is negative 3. So you say minus 3 minus 3. So 2n squared plus n minus 3. That will be the end term of the sequence. That will be the end term of the sequence. So with this, we come to the end of this class. So the next class, we're going to do cubic sequence. We're going to do cubic sequence. So you write the end term and show to us. Okay, write the end term. Okay, thank you very much for joining us today.